So we already covered the first normal form, second normal form, and third normal form. In first normal form, we have removed the multi-values because we still have a partial function dependency in first normal form. In second normal form, we remove the partial function dependencies, but still there is a transitive dependencies there. In third normal form, we avoid that non-transitive dependency by removing it. Now we have BCNF. In BCNF, we consider all the determinants as candidate keys. So, for example, if you're saying that in our table we have employee ID and department number as a candidate key, so this will be our BCNF, and we will create employee name, salary, position, and so on. Okay, or department name, etc. So you can provide more information here, and these two of the BCNF we mostly use in complex databases. So these two are mostly used in the complex databases. For the 4NF, we have what we do is that we took that multi-value we had earlier in first normal form. So we were saying employee ID we had, and we had multiple values were given there. So what we do, we take each of the value and we create a relation out of it, which means E001, E001, 2, and 3. So which means out of each of the multi-value, we take over each value, we create an entity out of it. This is 4NF. Okay. So now let's look at the example. So I will just explain the example number one, which we have covered in the class as well. So I have given you one relation here. So this is an original schema for you to understand that how these FDs are derived. Original schema, and these are the FDs. So whenever you have such kind of questions, you always have to look at the FDs. Okay, which means you already have given you a normalized form. So here in FDs, we have to identify the candidate keys. So as per these FDs, we have two candidate keys are here. Okay, so student number and primary majors are considered here as a candidate keys. Which normal form is a relation in? So we know that the student number is actually a primary key, whereas a primary major, which is mainly like CIT, CST, which means these major is considered here as candidate key. So is it a partial dependency is there, transitive dependency is there, or multi-value is there? We cannot assume the multi-value because we cannot see the values here. Okay, we do not have a populated data here. We have only attributes. So it is a second normal form. How it is second normal form? Because we have a primary major which is acting as a partial dependency. Okay, which is a non-key attribute. It is a non-key attribute or non-prime attribute, which make it a second normal form. How we can convert the relation into a set of relation or third normal form? We'll keep a student number as a candidate key, name, and prime major. Then you can see the hint here you have is for the school, which means you need to include your own candidate key, which is not present here. You have to identify the candidate key in school num. And we can say here that we have a school, which is actually a school name. Now we do know that there is a relationship between a student and a school. So we will include our foreign key in a weak entity. Why school student is a weak entity? Because students cannot exist without a school. Okay, so which means student entity is a weak entity. So you place a foreign key in a weak entity.